All right, we're combining like terms and we're using the distributive property. Now, like, not all of these will use the distributive property, but several of them will. So one thing I did for every class is I did 1, 4, 7, and 10. So the reason I did that is because, again, I wanted you to feel like, okay, yep, that's exactly what I was expecting it to look like. That this is 8r and this is negative 11r, and those are like terms. This is negative 5y and that's positive 13y. That would combine to make 8y. Negative 7 and positive 6 would be negative 1. And then right here, 4 times x. Well, hang on. First of all, I cannot do what's inside of these parentheses. They're not like terms. So after that, it is the distributive property. It's multiplication, right? So we get 4x, and then we get 4 times 9, which is 36. Now, I wrote that plus sign awfully fast, but the reason for it is because it's positive 4 and positive 9. So it's plus 36. Next, same thing as the previous one. We cannot combine these, even though they're inside the parentheses. So we're going to distribute negative 4 times 3n. And if you're like, but I don't get why we're multiplying, why did we multiply here? Why are we multiplying here? Is because when that 4 is that close to the parentheses, they're saying, listen, we have 4 of this, okay? Just like right here, when we're saying 4x, this is saying I have 4 of that, okay? It's just a different shaped box, so to speak. So back to this one. Negative 4 times 3n is negative 12n. Negative 4 times 1 is plus 4. Why? Because a negative times a negative is positive. Now we combine it a little bit more, get a little bit more complicated, and then we're going to do number 13. So right now we have 3 times m minus 4 plus 8m. So we're always thinking about PEMDAS. Do we have parentheses? Yeah, we do right here. But can we do m minus 4? The answer is no. How come? I have no idea how much that is. It could be 1,000,000, it could be 2. So I can't do 1,000,000 minus 4 if it's really 2 minus 4, right? So we're done with parentheses. Do we have any exponents? No. No exponents. But we do have multiplying. Where? Right here. So what we're going to do is distribute 3 times m is 3m. 3 times negative 4 is negative 12. And then what we're going to do is this plus 8m just drops down. How come? Because we didn't do anything with him yet. So we should really go double check. No parentheses, no exponents. This right here, this is technically multiplying, but it's already done. Like, I can't do it any further. This is technically multiplying, but it's already done. I can't do it any further, so I'm done multiplying. There is no dividing. There is both adding and subtracting. So if you remember, I told you that multiplying and dividing are on the same level. So are adding and subtracting. And so you do those from left to right. So here we go. We have 3m. Actually, so hang on. Maybe I shouldn't have, well, it's not that I shouldn't have mentioned that, but maybe it doesn't matter because check it out. It's 3m and positive 8m. That's just 11m. And then we just bring down the minus 12 because we didn't do anything with it. So what I was gearing up for of doing left to right is, in my mind, oh, it was going to be 3 minus 12 plus 8, but oh, whoops. He just drops down right here, and we're done with this one. Next, let's check out 19. So let's write down PEMDAS, and then let's see what we got. We have 11a minus 2. This 2 is multiplying 2a minus 11 plus 16. So, do we have parentheses? Yes, we do. Can we do what's inside of these parentheses? Can we do 2a minus 11? No. So we're on to exponents. Do we have exponents? No. do we have multiplying or dividing? Yeah, so let's do that. So here's what happens. That 11a drops down, not touched. That plus 16a, that plus 16 drops down, not touched, right? Next, negative 2 times positive a would be negative 4a. Let's see. Negative 2 times negative 11 is positive 22. Now, what do we got? We have 11a minus 4a plus 22 plus 16. So really, now way over here, we're done with multiplying and dividing. We're going to do adding and subtracting. So 11a minus 4a is 7a, and 22 plus 16 is 38. We're done, just like that. Now, I did that one in class. I want you to be able to try 21 and 22 on your own, but let's go ahead and do one of them, just so that you can double check yourself. So check this out. We'll do 21. We have PEMDAS, right? We have parentheses. But if you've noticed, pretty much every single one, in fact, let's zoom out. Every single one, we could not do anything inside of the parentheses. None of them were like terms inside the parentheses. So really, we're done with the parentheses. We don't have any exponents on the whole thing. So now we're ready to multiply and or divide. So that's multiplying. That's multiplying. So let's distribute. Negative 4 times n is negative 4n. Negative 4 times negative 1 is positive 4. 7 times n, a positive 7 times a positive n is positive 7n. Positive 7 times 70, well, I just told you. Positive 7 times 10 is positive 70. And now we are done with this. We're ready to add and subtract. Will you always be that way? Well, it depends on what's left over, right? Because again, this is technically multiplying right here, but we can't actually multiply those. That's multiplying, but we can't multiply them. Why not? They're already simplified. So, negative 4n plus 7n is 3n plus 4 plus 70 plus 74. That's it. Let's see, are there any others that, you're going to want me to do the fraction one. So here's what I'm going to do on the fraction one. Not do it. I will help you. What if I did 2/3 times, you know what? What if I did 2/3 times 12k? No, I won't do the exact same number because then, yeah. Let's see, how about 9x minus 27? And you might think, holy cow, why is he doing such big numbers? You can do this, okay? So what's happening is, again, inside the parentheses, we can't do it, but we can distribute this. 2/3 times 9. Well, that's really 2/3 times 9 over 1. Now, if you are confident and comfortable, if you're not confident, you're not comfortable, multiply straight across. And you get that. But if you are comfortable, and more experienced, then what you can do is, 3 can be divided into 3 one time, and 3 can be divided into 9 3 times. So then you would get 2 times 3 is 6. 1 times 1 is 1. And guess what that equals? That equals 18 over 3, because if you divide 18 by 3, you get 6. So check this out. These are all 3 the result of this one multiply right here. And if you're like, which one do I pick? What should I do? I was just showing you that if you got this, you got 6. If you got this, you got 6. If you got 6, well, duh, you got 6. Next, let's do 2/3 times negative 27. 2/3 times negative 27. Well, as you saw right here, we just put it over 1. So guess what? I'm going to do that right here, over 1. You can go straight across, and you get negative 54 over 3, which both of those can be divided by 3, but guess what? You could divide that by 3 and that by 3, and you would get 2 times 9, 2 times negative 9, by the way, which would be negative 18 over 1 times 1, which is 1. Guess what? Negative 18 over 1 is also equal to negative 54 over 3. So it's just negative 18. So the answer to my made-up problem right here is 6x, because I made a boo-boo. I did not include my x right here. There should have been an x, and I should have had the x right here. And so the x is there. So 6x minus 18 is what would be the answer to my fake problem right here. You can do this, okay? Don't act like you can't do it. If you have any questions, let me know. See ya.